talk about some stuff. So at this point, we've gone through 7.1 and 7.4 and then 9.1 through 9.3, right? So anything kind of in that region, or it could be just broad as well, doesn't really matter whether it's specific homework problem or just kind of like a broad question about like, hey, what's going on right now, or good. Yeah, the 9.3 should have been, if you get it, it's very algebraic. So, Jack.
Would you mind doing number 17 through 7.4?
Sure. 7.4, 17. All right. So again, the idea here was going to be doing these partial fraction decompositions, right? So first thing I want to check, the degree of the denominator is 3, right? Because I have a first times a first times a first.
Yeah.
So that should be a degree 3. The numerator is degree 2, so we're good to just go ahead and dive right into our partial fraction decomposition. If I look at the denominator, the factors in the denominator are all uniquely linear. So I'm just going to have my decomposition is just going to be 3 rational expressions, so 3 fractions. So I'll have one with the denominator of y, one with the denominator y plus 2, and one with the denominator of y plus or minus 3. And then we'll just multiply both sides by this denominator. So we do that, clears the fractions. So we have a times y plus 2 times y minus 3, b times y minus 3, and c times y plus 2. And then we'll just multiply the right-hand side out. So we have ay squared minus ay minus 6a plus by squared minus 3by plus cy squared plus 2cy. Oops. Plus 2cy.
I think that's what I messed up by distribution.
Ah, should we finish it out?
Might as well.
Okay. So now I'm going to set up a system. So I know that this coefficient of 4 must be the result of a plus b plus c. And the coefficient -7 should be the result of -a plus -3b plus 2c. And then our last one, -12, should be the result of -6a. That's it. And again, this system would be relatively easy to solve because it's not a real 3-variable system, because that last line is just, a single variable. I'm still just going to do it in the calculator for the, just to run through doing that again. So I'm going to type in my matrix. This has 3 rows and 4 columns. Again, it's important when you're setting up your system that the equal sign is always on the right-hand side, that your constants are your last column, or the solutions are your last column, and that the variables all line up vertically, so all the A's are stacked on top of each other, the B's are stacked on top of each other, etc. So I've just gone and typed in my coefficients into a matrix. Go back out to the main screen, matrix menu, math command, looking for RREF, and just doing that to the matrix that we just wrote. So A is 2, B is -9, and C is 11. So now we're ready to go back to the calculus piece after that diversion to partial fraction decomposition land. So this allows me to write this as, I'll do it this way, 2 times the integral of 1 over y dy, minus 9 times the integral from 1 to 2 of 1 over y plus 2 dy, plus 11 times the integral from 1 to 2 of 1 over y minus 3 dy. And each of these are pretty easy. So 1 over the y, the antiderivative is just the natural log. And then 1 over y plus 2, again, it's a chain rule, or a u sub, but it's like a nothing burger u sub. Yeah. We've talked about those, and the same thing here. And then I just need to evaluate everything from 1 to 2, which is just calculator time at that point.
Okay, thank you.
Sure thing. Does that feel okay?
Yep.
Again, like, it's the algebra stuff. There's so many of these little algebra steps that it's easy to kind of get lost in the sauce or make like one little trivial mistake and have a hard time tracking that down afterwards. Yeah. Especially on these partial fraction decompositions where it's like you got to FOIL stuff out correctly and there's a temptation to just do it all at once, and like sometimes that works out really well and sometimes you make like a silly mistake and then you can't go back and figure out where the silly mistake is, and it just kind of snowballs. And like, I get it. Yeah. I get it. But that's the gist of it, right? So it sounds like you had the right idea. You just kind of like stumbled a little on the execution. Okay. Any others for right now? Okay, fair enough. We can always circle back and hit those up next time. Today we're going to go a little out of order. I'm going to do 9.5 today, and we'll do 9.4 tomorrow, or next time I should say. Mostly because I think 9.5 pairs better with what we just finished in 9.3. So what we're going to be looking at in 9.5 are something called first-order linear differential equations. So we call it a first order, again, because the derivative is just the first derivative. And then it's we say that it's a linear differential equation if we can write it in this form. So we have the derivative of y plus some function of x times y equal to some other function of x. So if we look at this example down here, if I divide both sides by x's, or by x, I will end up in that form, right? Where there is my derivative of y. There's my function of x. There's my times y. And there's my other function of x. Notice that a constant can still be a function of x, right? No problem there. Okay. But the question really would be like, Mr. Kulik, why can't I just do this using separation of variables like we did before? Right? Like we just did this kind of thing. Hi, Sophia. We just did this kind of thing in the previous section. What's getting in my way here? Well, what would we try to do if we wanted to separate this and get the y's in one place and the x's in the other? What would kind of happen if we tried to do that? Right, this is dy dx. And then what would we try to do? Go ahead. We're just making ideas.
If you divided x,
Okay.
you did the x on one side, then multiply dx to the other side, that'd be 2 dx.
So I'd have dy plus y equals 2. Oops. I'd have dy plus y dx equals 2 dx. Right? That's what you're talking about doing?
And then wouldn't that be, you have to do it.
Well, I can't because I don't have them separated, right? So I can't integrate at this point because 1, I don't have y times dy, and 2, I still have that dx attached to a y. So like that's not the right variable to be integrating with, or with that differential attached to it. Elvis?
Where is that x?
Oh, we divided both sides by x. I forgot to write it down on the next step. Thank you. So going from here to here, Luke said to divide both sides by x and then multiply by dx. So it's just like it's not separable in that way, right? It's just not going to work. But I claim that this is something we can do still. So here's going to be the trick. Is I want to think about this right-hand side as the result of the product rule, a product rule differentiation with y and some other function of x. Now, right now, the way it's written, maybe you can see that, maybe you can't. And maybe it's not even really set up as a product rule differentiation. But we're going to make it the result of a product rule differentiation by multiplying both sides by some other function of x. That's kind of the goal here. So if you looked at that carefully, you might have seen that, hey, if I took the derivative of x times y, that's a product rule. That would give me x times the derivative of y plus y, which is exactly what we had. So if I think about that now as the derivative of the product x times y equals 2x, I can now integrate both sides because this is just a fundamental rule of calculus, right? The integral cancels out the derivative. And the other side has only a single variable. So no problems integrating now. So that gives us xy equals x squared plus c, and then I just divide both sides by x, and we're done. Now, the question becomes, okay, what if that left-hand side isn't actually the result of any product rule? Right? Here it is. We could kind of see it when I pointed it out to you. But what if it wasn't? What we're going to do in that case is multiply both sides of the equation by some function of x so that we make it the result of some product rule derivative. So let's kind of look at this generally, right? So I have dy dx plus p of x times y equals q of x. That's my general linear form. And what I'm going to do, or what we're going to do, is multiply both sides of the equation by some function I of x. We call that function the integrating factor. So that has a name. Now, we'll talk about how to find that integrating factor in a moment. Just go with me now and just assume that we can find this function. I'll show you how to do it in a minute, but we're not going to talk about that right this second. I want to show you kind of why this is working. So we're going to pick some function I of x such that I of x times the right-hand side is just the derivative of I of x times y. That's our goal. So if we do that, we can take our starting equation and then multiply both sides of it by I of x. And here I just chose to rewrite this as dy dx as y prime. Just for, well, it was a lot easier to type it in, to be quite honest with you. So we had said the way we're choosing our I of x is we get that for free. That I of x, when I multiply that to the left-hand side, just makes that left-hand side the result of some product rule derivative I of x times y. So now when we integrate both sides, the integral cancels the derivative. So my left-hand side just becomes I of x times y. And we just divide both sides by our I of x. Notice that the right-hand side is all functions of x. So we are good to go. We've accomplished our goal. We were able to separate this to get the solution for that differential equation to tumble out. This looks bad because the notation is a little bit heavy here. In practice, the stuff that I'm going to ask you to do is not bad. Or no worse than anything that we've done to this point. So let's talk now about how do we find this I of x, right? We just took for granted that we can do this, that we can find the I of x that we need. Now it's time to really show that, like, okay, how am I going to do that? So this is the way that we find that, or the way that we're going to figure out how to find that I of x. So we need this to work, right? When I multiply the I of x to the left-hand side, it needs to be the result of the product rule derivative I of x times y. So I'm going to go ahead and set those two things equal to each other. The left-hand side, I just distributed the I of x through. The right-hand side, I did the product rule derivative. Look at what happens here. I of x times y prime is on both sides. Subtract that from both sides and it just cancels out. Now if I look, I have a y on both sides. Divide both sides by y, and I have that p of x times I equals I prime of x. This is just a separable differential equation. I'm just going to divide both sides by I of x to separate the p of x's and I of x's. And now we can integrate. So the integral of p of x d of x plus c is just going to be the natural log of the absolute value of I, right? Because we integrated 1 over I. So, drum roll, if I want to get the I by itself, it's just going to be a times a constant a, e to the integral of p of x dx. And we can do this every single time. It's now just a formula. I love it. So we formalize this with the statement here in the pink box. To solve the linear differential equation, y prime plus p of xy equals q of x, multiply both sides by the integrating factor I of x, which is equal to e to the integral of p of x dx, and then integrate both sides. Okay, example time. Because this looked a little brutal here for a minute. We're going to show you that it's, in practice, really nice. This works quite easily. Okay. So, solve the differential equation, yada, yada, yada here. So, I'm going to first start by making sure that I'm in that linear form. So I need this to be y prime plus p of x times y equals q of x. So I have y prime, I have p of x, I have times y, and I have another function of x. So it looks good. Everybody okay? All right. So we're in the linear form. Next thing we're going to do, we're going to figure out what our integrating factor is. From the above, that is just going to be e to the integral of p of x dx. What's the antiderivative of 3x squared? X to the third over 3. Oh, not over 3. Over times 3. Everybody's okay? So now, multiply both sides of our differential equation that we're trying to solve. Oh my goodness, Mr. Kulik. X cubed. By our integrating factor. This, I'm not even going to look at, because what does this turn into? It's the integrating factor times y, where I've taken the derivative of it. I don't have to think about it. I get that for free by the way that I've chosen that I of x. The right-hand side.
Will that always happen?
Yes. That's the point of of choosing the I of x in the way that we've chosen it, is to guarantee that we can able to make that compression, which is wonderful. Taylor.
Always like that. It always ends up being e to whatever that is times y.
This formula that we use to do this is the same every time. This compression that we did here will always work if you're using the I of x as we've described. Yes, yes, yes. Don't you love the always answer?
Yes.
It's wonderful, right? Okay. So we're here. Integrate both sides. Fundamental rule of calculus says if I integrate a derivative, those things just cancel out. Right? That's cool. The right-hand side or left-hand side, super easy. How am I going to integrate the right-hand side? I guess I should have a dx here. Yeah, you can just do u sub. You don't need to do integration by parts. What will the u need to be? X cubed. So du is 3x squared. So we'll just think about that as a 3, and we'll push the 2 out front. So that's just the integral of e to the u du now. Everybody okay? Or 2 times the integral of e to the u du. And then I can't forget my plus c because it's an indefinite. And then my last step to get the y by itself would be to not subtract, divide. Yeah. So when I divide 2e to the x to the third, those cancel out. But I also have to divide the c by it. I'm sorry, what was that, Elvis?
Is it not still going to be like C?
Well, it's not going to be a c if I divide it by something with a variable in it, right? It's going to be the constant stays a constant there, but like it's a variable thing dividing it. It still needs to have the variable thing dividing it. You know what I mean? That can't absorb up into the c. If I divided it by a constant, then yes, we could do that. Paul, what's up? Certainly. So this turns out to be, that's not too bad, right? Did anybody notice anything about the beginning here, this problem? I think this was separable. Just as a aside. So you could have still done this using the methods from last time, and you will end up with the same result. So just so you can see, the method we've described allows us to do things we couldn't previously do, but it still works on things that we could do, right? Everybody's okay? I just wanted to point that out to make sure that we can see that these are like overlapping methods, right? That they still can do some of the same problems. Okay. All right. Let's look at this next one. Let's try you guys working on this. So in your notes or your separate sheet of paper or the back of your hand or the inside of a matchbook or whatever you want to be writing on, try to do this. Periodically, I'll kind of write in a next step. So if you're working on this and like you've goofed up finding an integrating factor or something, or if you've forgotten to do something, you'll kind of, oh, oops, and you can go back and kind of make some corrections, because we've seen in these, like problems that require a lot of steps, that if you make a goof in the beginning, it just, it's hard to kind of go back and error correct that out. So go ahead, start trying to do this. Again, you want to start by getting the thing in the linear form, figuring out the integrating factor, multiplying both sides by the integrating factor, and then you can integrate. But take a few minutes. I'll kind of add some steps in as time goes on. So periodically when I do that, I'll announce it. You can look up and see what I've added in to make sure that what you had done was still correct. But everybody should try to take a stab at this. Find some paper that's somewhere, your tablet, separate sheet, whatever. I know some people are particular about their notes being organized and don't want to do this in their notes, and that's okay. Just find some scrap paper somewhere. But we're just going to try to do this, and I'll kind of add in some steps as we go. So that's the linear form, right? Why was it okay to divide by x squared? I divide by a variable. X is non-zero, so it's okay to divide by it. That's always the fear when you divide by a variable. You have to be able to justify to yourself that it's not zero. You do not need to worry about it. What ends up happening is it just kind of gets absorbed into the constant at the end when we integrate again. So we don't really need to worry about it there. Yeah, that's a great question. So I got x as my integrating factor. Question for you guys though, first. Why was I able to drop the absolute value sign here? Yes, yes, well done. It's that x is greater than 0 piece again. That makes life just a lot easier, right? Because nobody wants to integrate an absolute value. Yuckarooskies. So after I multiply both sides by I of x and compress, I should have this. Well, I multiplied by both sides by x, right?
Oh, yeah.
So it was 1 over x squared. But not anymore. What do I need to do with y of 1 equals 2? What's that doing in there?
You're solving for C.
Yes, solving for C. Excellent. Remind me again, what's the natural log of 1? 0. So C equals 2. It's not so bad, right? Again, I think easier than some of this, a lot of the stuff we had been doing. There's another one on the bottom. You want to start on that one if you're finished. If you're still finishing this one up, that's cool. Take your time. We have lots of time. There's no rush. I just don't want to hold back the ambitious folks that are like, I'm rip-roaring to go. I cranked that one. I'm ready to get some more practice. I think I got it. Jillian.
Can you explain how the C goes away again?
Well, the C I solved for in this step, right? The natural log of 1 is 0.
Yeah.
So 0 plus C divided by 1 is just C. So I have C equals 2. And then I just plugged it in here to write 2 in my final answer.
Okay, because we knew about 1, 2, so that's why we could plug that in. Okay, I see.
Exactly
Okay,
right.
yep, okay.
Exactly right. Yep, you got it.
The compression just becomes x by prime because e to the natural log of x is just x, right?
Mm-hmm. Yeah, so you're always going to have I of x times y when we
And then e to the
compress.
natural log of x is going to simplify to just x.
Correct. Yes, 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 yes. Exponentials and logarithms cancel each other out. You have to be a little bit careful about how you're doing that, but if the bases match, it's a one-to-one canceling, which is lovely, because the natural log is just log base e. That's great. Again, as you're doing things, if you have questions or whatever, if you're not sure, or if I write something you're unsure about, speak up. We can talk it through. You know I make mistakes from time to time. Elvis caught me once already today. So the next one, we're already in linear form, so nothing to do there at the start. So I just dove right in to find the integrating factor, which should be e to the x squared. I multiply both sides by my integrating factor and compress. Oops, need the prime mark. At that point, we're ready to integrate. How do we integrate e to the x squared? Well, what would you make your u? So u is x squared. So du would need to be 2x dx. Do we have another x rattling around there? No. So u sub's not going to work there. There's only one part, so we can't obviously integrate it by parts, right? Well, just going to leave it. We'll divide both sides by the e to the x squared. And now this answers, plus c. Probably should have put one there too. Now this answer's okay. I would prefer though, to write this using the fundamental theorem of calculus to say, like, this is the integral from 0 to x e to the t squared dt over e to the x squared. So it's like really a function of x. But I would bet that this answer would be, oops. All right, hold on 1 second. We got a couple of boo-boos here. The plus c needs to be up there. My suspicion would be that the back of the book probably has the one that's squiggled as their answer. But I love the second answer that I boxed up, because you're really using that fundamental theorem of calculus to write that integral as a function of x with the dummy variable t. Remember doing that way back at the beginning of the semester? Paul says no. Jillian says yes. Vaguely. That's okay. But that might have been surgery time still for Paul, where he's still like in a bit of a haze, limping around. You were back, I think, by then, but
Yeah, I wasn't that bad.
yeah, I understand. I understand. So that's the gist of 9.5. This felt like a better piggyback to 9.3 than taking a detour into application land for today. So the assignment for 9.5 is 1 through 19 odds. We got a bit of time. Do you want to do some of these together here? Right? It's always fun. Get a start on the homework. As you've seen, these really aren't too bad. You're welcome.
That was so sneaky. That was sneaky. I've been in here since the beginning.
I know.
Wait, have you actually?
Jillian's unaware.
Well, that's good that you're always like this, you know, I wasn't just being on your best behavior. I was back there watching the class, so it's probably better.
I act differently.
He said, I act differently when you're around.
Better or worse?
It depends.
Well, what did you think?
I thought they were all pretty good.
Yeah.
You know, except Sergio.
Not expected though.
All right, you guys.
See you later.
Oh, I was. I mean, yeah.
You like staring right at something
I like this.
Well, that's what happens when you're like the disciplined person, is you inherently become sneaky.
That's funny.
Like
What was that
something-
for? Was
Just
you
so I look at the
evaluating
No.
Yeah, why was she in here?
No.
Just do an observation.
Back, I'm like, oh, that makes sense.
Everybody gets observed every year at some point,
Are you still teaching?
as far as I know. Nobody's told me otherwise, so I'm going to keep doing it. All right, let's take a look at some of this from the homework, right? Let's bang out a couple of these, get you a little bit less to do, make sure we're started. Number 1 says determine if the differential equation is linear. What do you think? So one person says yes, one person says, I would agree no, not as currently written, but can we put it into the linear form? You just add the derivative of y to both sides. And then I have y prime plus p of xy and then q of x. Right? That'll do it. Everybody happy? Mr. Kulik, that was a tough one. All right. How about 3? Not right now, clearly. Can we get it there? Luke, you said no. Why are you dubious?
Because if you just made y prime dy dx and then multiplied 1 over y over and then divided, it is not linear because you can make it separable, or it is separable.
It is not separable. So the issue is the 1 over y. Subtracting it over is not going to help us, right? So if I do that, I have y prime minus 1 over y equals 1 over x. But I can't write that as a function of x times y, right? Remember that we have to have just a regular y. So to get that a regular y, I'd have to do something like, what would I do? Well, hold on, I have an idea. I don't know if this will work or not, but let's just try it. This might still work. I haven't looked at the answer here. What could I do here with 1 over x plus 1 over y? Yeah, what if we made a common denominator and added the fractions? And then we could do what now? I could multiply both sides by xy. And then I can subtract the y over. And then what? We could like factor a y out, but I don't think this is helping us get anywhere, right? No, this looks worse. I'm content that this is no. I tried all the sneaky things I could think of. I can't get it to go. Let's just double check in the old answer book here and make sure. Yep, they agreed. Number 3 is just no. Woo! Good.
I was writing this for the wrong reason.
You know what? Like, sometimes that's all that matters, right?
Multiple choice test.
And a multiple choice test, I'll take it. I'll take being right for the wrong reasons all day long on a multiple choice test. Absolutely. All right. 5. We have y prime plus y equals 1. Is that separable? Definitely not. Why not? Because how the heck are you going to get y times dy if I have y plus dy? Can't combine those together, right? So have to try what we're been doing. Is this in the linear form? Yeah, right? What's p of x in this case? 1. So that's that. That ought to do it. What do you think? That was pretty easy. It should be. It's like the first one in the section of doing these, right? It's like they're not going to give you like a 15-stepper to start off with. I don't really think there's going to be a lot of 15-steppers in this homework set because it's pretty straightforward. You're doing kind of the same thing all the time. Should we do 7? Let's do 1 or 2 more, right? What's up?
Ross was saying they always manage to put a 15-stepper in that interval. And I said for that one, I just put asking to pull it.
Sergio always asks so many questions in class. You always follow something.
Yeah, Sergio's a notorious question asker. But it's always about like, do we have to do this homework? Can we? What if we make the test like optional? These are Sergio questions. They're always looking for loopholes, not actually content.
No. I asked like 2 like genuine math questions. But yeah, it was like one class. I don't know what was up. I was like feeling like frisky that day.
Okay.
Yeah.
Is that what you just said?
Yeah.
Uh-oh. Well, how do you integrate x e to the x? What's that?
So x dx minus
Right, but like, how did you do that? I realize you typed it into your calculator and did the integrate command on it, but like, how would one do this without consulting their CAS-powered calculator? By parts. Absolutely, great. So what part should be our u? X, great. And dv then becomes e to the x. I'll just write it as dx. Everybody's good? So we have u times v minus the integral of v du. What's the integral of e to the x? Just e to the x. And we still have our plus c. So far, so good. Then we just divide by e to the x. That looks pretty good to me. What you guys think? Not too bad, right? This is pretty doable, right? Will they get messier than this? Yeah, probably as they go on, you'll get a little messier, but it's not going to be like bonkers, right? Because it's like it's just one procedure, just do the procedure, right? Well, can you catch an integral where you might need to use like, parts? Sure. Could you possibly catch an integral where you have to do like partial fraction decomposition? Sure. Could you catch an integral that you just flat out can't do and you have to write it as part of the answer? Sure. But I gave you all the odds, so you can check and be like, oh yeah, look, this is one that you can't really do the integral on, right? So I intentionally tried to pick problems that, when there's that kind of ambiguity, you don't have to worry about it too much. So just talking about the schedule, Monday next week we'll finish up chapter 9 by doing 9.4. We'll do our review day on Wednesday, and ideally we'll take the chapter 9 test on Friday next week. That'll be the last test. The last real required AB content. I have a couple of things that I'd like to do. I think that are standard Calc 1 and 2 things that you would likely see in your Calc 1 or 2 class that I'd like to still get to. But we'll just kind of mix those in as we do specific AP reviews. So my plan would be multiple choice practices in class, and then give you a free response stuff to practice at home. Have you guys get me a digital copy of what you wrote. We'll go through, I'll score these things, maybe several of them that are good exemplars in class, to give you a feel for like how an AP grader is going to be looking at these things, and talk about like where we've given away easy points. Especially if you catch a rough grader, like somebody that's really a stickler, they should be pretty uniform. But I imagine that like some people are a little bit more flexible than others about, oh, you didn't write a dx on this, I can't give you points for this integral because you didn't put the dx in there or something. I know there's a lot of missing dx's on tests and stuff that I don't really make a big deal. I mean, I write them in for you in red or whatever, but that's basically going to be the format for the class. So we get a little bit closer, maybe we'll do a day in class where I'll get you a section, like print you out a multiple choice practice section. We'll do them in class and score them.
And then everyone puts in $5 to the pot.
Just
And the highest score
takes the money.
Absolutely not. Lowest score.
Of course. And just kind of reminder for you guys, the exam format is there, but it's 60 minutes of 30 questions that are no calculator, 15 questions for 45-minute multiple choice that are calculator. Then you have 30 minutes of calculator for 2 free response questions, and 60 minutes of no calculator for 4 free responses. I know, guys.
I can't not use my calculator.
That is insane.
Well, we're gonna practice it too.
Well, that thing gets me like
Wait,
everything. I'm
yeah.
telling
It's
you.
like 2 minutes a problem?
Yeah.
Three.
Multiple choicers.
Should we, 3 isn't we expected to finish that, or is the curve so massive to the point that they don't
Well,
really
well,
expect
here again, to keep in mind, remember that like a 70% is a 5,
Right.
right? Like a 50% is the borderline between 3 and 4.
Right. Okay.
So like, if you only did 15 of the 30 problems, but they're all correct, you're doing pretty good.
Right.
That's not a massive failure, right? Obviously, you'd like to do them all, but like if you can't, it's scored in such a way that like nobody's expecting you to finish every single thing.
Okay.
Like you're probably going to see stuff you're just like, I don't know what to do with this. And to be honest with you, on a multiple choice, I would never leave anything blank.
Right.
Even if you're just guessing out, maybe you can pick up 25% of the last ones, like if you get 15 that you know are right, and then the last 15, you're like, if I get 5 out of those 15, I'd feel pretty good about having 2/3 of the questions, right?
Right.
That's pretty good. That's solid 4 land with a possibility of sneaking into 5 if you nail another section. So again, like I think will be one of the hardest parts for you guys is taking this test, feeling like you're failing and still keep going and trying hard through to the end.
I was gonna say, it's gonna feel really demeaning to walk out of there like I just studied a bunch and then
Yeah.
bombed it.
And like, that is normal. That is what this is going to feel like.
I
Okay?
like how like STEM classes are in college.
Depends on like your instructor or whatever. But like, that is how this is designed to feel. When it's this tightly timed and asking you to do this much stuff, most kids, they get like 3, 4, 5, especially if you're like a low 5, are gonna walk out of there feeling like, I just failed that thing. Because you're used to like exiting a test and getting like 80s and 90s on tests and feeling, okay, that felt all right. This probably won't unless you just nail it, right? Unless you're the kid that's gonna get,
Just say, I kind of want that plaque though. That says
like,
all CrossFit perfect.
I don't,
You have a perfect score, maybe.
Yeah, but I think it's like if you do that one month, it's just more each test.
You get every single question. I don't think I'm gonna do that.
but like,
I'm not that good at calculus.
I mean, here's the thing, like, honestly, with what we've done and what I've seen from you guys, there's no one in here that should be thinking less than a 3. Like, there's no one in here that can't get at least a 3 on this. I promise you. If you prepare and you try the entire test through, that is not an unrealistic score for any single person that we have in this room. Or the other room, the other section. Like that, those are real scores that are perfectly attainable. The big thing is you can't quit and like give up, particularly on the free response stuff. That's the place where like give ups happen. And like, if this is not your strongest suit, you can't give away, just take a 0 on a section, right? Like that's just not going to help. Like you have to just keep going, do stuff. When we start practicing the free responses in earnest, we'll talk about like things that you can just like, hey, we know this, like, can we just write some stuff down? A lot of the sub points are just for like noticing things. Like, can you like, oh, I looked at the graph and figured out that this point has to be this. Like that could be a point. All you did was read something off a graph and write it down. Like I looked at the work for you guys is when you did those free response questions for me on the asynchronous days. And there's a lot of points that got lost just because we didn't write stuff down that we knew. And I could tell you knew because you ended up getting the final answer, but you didn't give me like any intermediate stuff for me to give you any sub points to it.
I didn't know we were supposed to like show that.
Yeah,
I literally wrote purely the final answer.
Yeah, that's okay. That's okay that's what you did. Like that's part of like getting ready for this process is for us to go, okay, this is what I would do without anybody telling me any differently. And now Mr. Gulick's going to be like, okay, so like if you do what you would just instinctively do, this is what you're going to end up getting a score-wise, and you're going to miss out on all these intermediate points. Even if you get all the final answers, if you're able to do the final answer for all of them. Like justifications was very lacking, really kind of across the board. Some of us were fine and did great. But when we did bad, it's almost entirely from people just like not including justifications. Bart, I'll continue to give you the same pep talk for the next month because it's my honest, real opinion of your own abilities. It's real, guys. Yeah, Amanda.
You did remember about
On this homework set?
Yeah.
Sure. Let's take a look. Good on you for just like grinding away while I've been flapping my gums here. Okay. So 11, we have sine x dy dx plus cosine x y equals sine of x squared. Yuckarooskies. That sine of x squared I hate. All right, first step would be to get this in the linear form, so I'll divide both sides by sine x. So this guy right here is my p of x, right? Oops. So that I'm going to do as a u sub, I think. So if I pick u to be sine x, du would be cosine x dx. So I'd be integrating 1 over u du. So that's just going to be e to the natural log of sine x. Did they give me anything else here about this that I can drop that absolute value? Probably not. Okay. Okay. So I just end up with absolute value sine x. So I have then absolute value sine x times y equals sine x squared over sine x times absolute value sine x. Okay. Why did they drop the absolute value here? Why did they do that? They did it. Let me think for a minute. Because I'm looking at the answer key, and they've certainly dropped that sine x, and I can't figure out, or the absolute value on the sine x. I can't figure out why they did that. Let's just pretend that that's okay for a minute, and we'll finish it out, and then we'll come back and think about it a little bit more. Now, I don't know how to integrate sine of x squared. Can't u sub it, can't part it. That's just going to be what it is. So that's going to be like, I'll write it this way because I think I like that way a little bit better. But there's my y as a function of x. Let's think for a minute. So sine x doesn't. Well, Amanda, I don't know. I mean, I think that they probably meant to do something like this or something.
Yeah.
And if they do that, then everything is fine.
Yeah. Okay, thank you.
That's all I can come up with as to where the absolute value went to on that. Best I got. Yeah, of course. Happy to do it. Boy, that's a mess looking of notes there, but whatever.